Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our advanced modeling episodes.
So first off, many thanks to Valdemir Goluza, Bosnian, for this speed reducer, a very well executed model that I downloaded from GradCAD and will be helpful for showing this particular tip. So if we look at this model and just collapse the tree, we have something failed in this in 3 of these sub-assemblies, and I have from the top of the tree, I have no idea what it is. It doesn't look like they're mates, at least at the top level. So I could spend a lot of time traversing through the tree to figure out what's going on here. But one thing I do as a tip when I'm faced with this kind of issue is I'll use the isolate command to help me out on this. Now, we know about the isolate command for modeling. It's just fantastic. When you have many bodies or many assemblies, you can use isolate to kind of reduce down the ambiguity of your model to model. But I find it really useful for repairing mates also. And in this case, I think it's a mate problem because I know there's a part that I changed here that caused this issue. So using isolate to debug is really great. So what I'll usually do is I'll pick the 3 failed parts and then do an isolate. And so now I've greatly reduced the kind of things I need to investigate. So now I can go into the model and into each of the failed parts. I can look for the failed features themselves. And so this is where it's kind of cool, is that I'm going to pick these 2 using Control, exit isolate, and while they're still highlighted, I'm going to isolate them again. So now I've really reduced it down so that I can see where my failed mates might be, and it is on this toolbox bearing. So if I go in here, I can see that I have a problem, and I'm going to take a look at that mate. There doesn't seem to be a problem with it, but I know from this bearing changing, this face has changed. And I think there's a draft in it now that's required by the forming tool. So we're going to, instead of using this face here, we're going to delete that and use this face. And then let it solve. Okay. So let's collapse our tree now. We've taken care of that problem. So now we can go and select these 2, turn off isolate, and actually get back it at the assembly level. So I'm going to isolate these 2 and start to investigate a problem here. And I see it's these 2 components, so I'm going to exit isolate, and while these are still selected, I'm going to isolate, and I can see that I have a couple of toolbox features here that could be part of the problem. So I'll go down into this part, look at the failed mate, and again it's on that bearing. So instead of picking this face right here, we're going to pick this face in here. If I can get to it. Let's keep going down with our selection. There we go. Nope. Let's just mate it to this edge. It'll be the same thing. Okay. Sometimes it's helpful to use a section view in the middle of mating to go and investigate and get a face also, just as a tip. So we're going to collapse our tree again, get back to the assembly level, and we're getting somewhere now. We've reduced the number of problems here. Let's go back and isolate these two. And we can see that this is pretty clean. We really have only a few things left to work on here. So let's select these three, exit isolate, and while they're still selected, let's take all of these, isolate them, and then let's see what we can do here. So we've got a failed mate here. Again, it's that bearing, and we're going to just pick this edge as a coincident. Okay, so now we're getting somewhere. So go back up to the top level, collapse the tree, and now we're down to one part. So let's find out where the issue is here. If we open up the subassembly by itself, it looks like it's clean. There's no problem. So it's probably at the top level. And by the way, just rebuilding took care of the problem. So that is how I like to use isolate to really quickly get through and repair things. Very helpful for reducing down to the problem and getting a chance to see it and repair it. This tip I really debated on whether I was even going to show it, but it might be worth showing it. I found it's rather limited in what it can actually use to repair. But this is about repairing sketches. And this tip comes from my friend Ed Eaton. When we were together a few months back, he brought this to my attention. I thought it was interesting, and then I investigated it more. So just in this very simple example I made up, we basically have a base sketch consisting of this sketch, and then on top of that we have another child feature which does offset entities on these three edges, and then a converted on this arc. So here's the deal. So if we go back into the base sketch, and let's say we carelessly just create a new arc right here, and we trim it back to the rest of the sketch, and then we delete this and we rebuild. Well, of course, the child feature is going to fail because I deleted that sketch entity. It doesn't know where to put it. So here's the tip. So if we go back into the child feature, we see our failed entity there. And then I very often use display delete relationships when I have situations like this. It's a big button up here, so you can't miss it. I usually get to it by right mouse buttoning and going to display delete relationships. And then you've got this handy filter to drop down to just what you want to see, and that is I want to see the dangling. So here I have this sketch edge 37 that's dangling, and I know it needs to be this edge right here. So with that, if you drop down into the dialog at the bottom, you get some information. Here's the dangling arc, 89. If I select that, then this selection box highlights, and it tells me that I can replace that dangling edge with the correct one. So if you just pick it and then click on replace, it will replace that edge automatically, just like replace face or replace sketch entity works. And then everything's cool. Okay, so before you get too excited about that, I have to tell you what the limitations are. If you do that command, and we'll go back to it here, and we look at this entity right here, you have to always replace the same kind of entity for another entity. What I mean by that is you have to replace an arc for an arc, spline for a spline, line for line. You cannot replace for instance, a spline with an arc or a line with an arc. It has to be the same type entity. Furthermore, offset entity doesn't actually work at all with this command. So I don't know why they actually lead you to thinking that it will, but it doesn't. And I've proved that out by some testing. It just doesn't work. So just know that those are some limitations there. Just to prove that out, let's go back in here and let's say that we replace that arc with some kind of spline. And we trim it back. And we blow away our arc. Okay. So, got a dangling situation again. Let's go to this view. Display delete relationships. Look for the dangling edge 37 again. So here I'm going to try to do this. So I'm going to pick that arc. I want to replace it with this spline entity. One entity for another. Single entity. Doesn't work. Okay. It wants an arc. It doesn't want a spline or a line. You cannot do that. Furthermore, let's kind of revert back, get our model back. Everything's cool. So let's try offset entity. So here I'm just replacing the same kind of entity right here with this entity right here, which will eventually be offset edges. So let's trim it to here. And I think this is freaking out because I have a midpoint right here. So let's just clean this up. And now we've got this. So let's rebuild, see what happens. Yeah, sure enough, it's dangling. So we know that this edge actually wants to be this edge. So let's try to replace that. So it's dangling 34. This dangling line wants to be this line. It doesn't work. So no matter what I do, try to pick this underlying sketch, offsets don't work here. So in this case, we know that we can repair it by just picking the edge and converting it, and then using our replace sketch. So I'm going to replace this line for this line. And then I'll just drag these to complete the sketch. And so there you have it. We still have something odd happening here, and I suspect that is probably the face that the sketch is on. Nope. That's good. Let's find out what else is wrong. So a very handy tool usually is to ask what's wrong. And it says unable to offset one or more of the sketch entities. Yeah, I've seen that before. So it really has to do with, even though it doesn't show you the error, the 10 millimeter offset is not working. And I think I can prove that by doing that, and yes, it regenerates without a problem. So you kind of get in some trouble there trying to do that replace entity offset, but eventually you can get through it by just using replace sketch entity. So how many of you use thin extrudes, especially if you're doing a lot of plastic design, you have bosses and you're building thin walls, and very useful to reduce the complexity of your sketches by just using thin extrude. Here we have a sketch that we want to build some thin walls between these bosses and bridge these with a strengthening rib. So if I were to, the way that this was created is, and a lot of times it's more complex than this, that I take these sketch entities, which are just lines, and I mirror them around the center line so that I can complete, four ribs at once with some logic in how I'm doing it with this mirror. So the problem then becomes usually, and this usually happens with mirrors, is I want to create my thin extrude, but you can see that they're extruding the wrong direction on the mirror. So they're extruding in. That's the way I really want it to be like this and about 2 millimeters. But they're going in the wrong direction. So if you ever have that situation, don't actually create two different features. There's a way around it, and the way around it is to actually just change the direction of these lines. Okay. So what you need to know about thin extrude is it derives, each of the SolidWorks line entities or any entities have a direction. And all we have to do is reverse the direction. Before I do that though, let me just do a really quick symmetry so we can get that back. And basically why I'm doing this is I want symmetry on these lines, but I want to be able to drag the endpoints. And here's what makes this work, is that I know the direction of these line entities is going the wrong direction. I'm just going to reverse that and use snapping to do it very quickly. Okay, so now with that, if I go to my thin extrude, and I'll just make that a little bigger so you can see it, I get them both going the right direction. And that is, I want them to go inward. And now I can complete my feature by just going up to surface. Oops, sorry about that. And there you have it. So we want to make sure though that merged. Yeah. That's how you can take thin extrudes, and especially when they're disconnected and you're doing multiple thin extrudes, you can take them and reverse their direction to get them working in a single sketch. Have you ever had this situation where you are creating a 2D sketch, let's say on this rotating cam surface, and we want to actually take this edge right here and convert it into the sketch, but it won't allow you to do that because the converted sketch is overlapping itself. And we know that SolidWorks does not allow that to happen. So how do you get around that problem? I don't really want to use this whole edge. I just want this forward edge actually, but I'm kind of stuck because anything I try to do to get that converted into the front plane is not going to work. So here's the workaround that I usually use, and that is I'll go and create a 3D sketch of the edge. So I'll right click, say select tangency, convert edge, and now I have a full edge in 3D. Now I want to convert 2D sketch onto the front plane. So what I need to do before I go do that is then go to Sketch Tools and split the 3D sketch in these two areas. And then I'm going to just carefully align that split with the front plane. I'll do the same here. And now, when we go to our front plane, we can take and we get a portion of that sketch. And we can convert it. We can even go and get the back also. Because it's a separate sketch entity in the sketch, it allows it to overlap. So that's how I get around that issue with overlapping converted sketch entities. Have you ever been faced with the issue of having a very large model, that is a model with a lot of features, and you want to retain part of it but to delete the rest of the tree? And when you do that, it takes forever and it takes multiple steps to delete your features out before you get down to what you want. I deal with a lot of large models, and this is an issue I come up against all the time. I'm actually hiding the model because it's proprietary. I don't want you to see it, but I think you can see the features here. Basically, this is, let's take a look at this model. This is about a 700 feature model. I want to retain everything in this folder, but I want to delete everything below it. So the first thing that we usually do is, okay, well, let's just shift select everything from there down to the save bodies. And of course, because there's so much in there and it has to all highlight, it takes forever. And here I'm kind of twiddling my thumbs, waiting for everything to select. And then once I have things select, I can hit my delete key. And again, it takes forever to evaluate those features. And then I'm left with deciding whether I want to delete the absorbed features. Well, that can be very dangerous because some of those features could be above the point of that folder that I wanted to delete. So there's some ambiguity there, so I leave that unchecked. I click yes to all, and I wait again, and I wait, and I wait, and I wait, and I'm waiting. I might have to speed up this video for you, depending on how fast this goes. Anyway, I'm just sinking a lot of time into something that's very simple, right? I just want this one folder and I want the rest of the model to be gone. But I'm waiting for it all to rebuild. And even when I get to that point, I haven't deleted all of my features. There's still a lot of sketches underneath here. So I have a better method to solving this issue. So I'm just going to reload this part, and show you. So let's go back to this part the way it was when I first showed you it. I won't rebuild it. I find that a faster way to do this is to suppress. Use suppress to your advantage. So I'm going to take and select all of these features. And we have to wait just like we did before, but once we get them suppressed, things will go a lot faster. So it's going through the tree, selecting everything that's going to be suppressed. And then I can right click, wait again, and suppress. So my hope is now that I can get these features suppressed, things can go a lot quicker when deleting. And okay, so we have most of the tree suppressed. What's important about what I just did is then I go into my front bezel folder features and look at them. If there's anything suppressed in there, I know that I've suppressed a feature that's being used in one of these features, and that can happen. And that's why I hesitated in clicking on the absorbed features. But now that I know that there aren't any absorbed features, I can take and select all of these, and then I feel safer about check marking delete absorbed features. And so when you do that, things move very quickly as far as delete, because it doesn't have to rebuild or recalculate the tree. And then there's a few sketches that are left over that probably had association to something in this folder. So I'll just quickly delete those. And that's how you can get through deleting large trees more quickly. When it comes to creating exploded views, namely for a drawing that's specifying a BOM of parts, I have a methodology that works really well, and you may have picked up on it too, but in case you haven't, maybe this is something for you. So we have this speed reducer assembly, and I'm going to create a new exploded view to eventually be in a drawing. So I'm going to create the new exploded view, and this is kind of my methodology here, and that is I first want to just kind of rough it out as far as exploding it. So I'll start with just selecting the entire assembly of one half of it and moving it out. And then at that point I'll start picking other parts that need to move with it. So I'm just going to pick these bolts carefully. See that I have everything. That looks good. I'll complete that step. Then I'll move to this part and move it out. Okay, and I'll also include with that move things that kind of logically need to go with it. So I'm going to just pick all of this. If I want to, I could actually fence select a lot of this and do it. So if I go into my my front view and just start picking this way, I can do that also, picking components to just speed things up. Go to the top view, do the same thing. Okay, so I'm getting somewhere pretty quickly. And maybe this goes too. So I've got a lot there. Now, often the case, I've missed some things when moving in my steps, and that's not an issue. If we go and to the exploded view and expand it, I know this is my step one. Let's edit that step, and let's just while we have this selected, we'll just go and include some more parts with that. Oops, I didn't want to do that. So that's a good show there that I don't want to include that. And then again, I can use like fence select to get some of this stuff. Yeah. So that kind of includes those bolts with that. It does mean though that these nuts probably should have gone on the other side. So I'm going to deselect those. And you notice I'm not worried about how far I'm moving. I'm going to get to that in a moment. So with that selection, I'll go to my second explode step here and edit it and include these nuts because they should go that direction with that explode. Get that last one. Okay. So we're done with that. Okay, so we have those two explodes. We can edit the main explode again and just do a few more components. Let's move this bushing out. Okay, I didn't want that because I want to select sub-assembly parts. So let's go ahead and just pick that. Yeah, that's more like it. And let's do the same for the bearing because they both kind of want to move at the same time. Let's take this guy and let's move it down. And then let's do the same with these sub-components here. With this, I want to probably also include the bearing. So you can see naturally it kind of goes with it. Let's do this bushing also. And then from that, we'll build another explode step on top of that to bring these and separate them. Okay, kind of get the idea. That's all its own part. So there's a lot more we could do here, obviously, but I think it's enough to illustrate. Let's maybe take and move this guy up and also this part. And then once we have that, then we build on top of this explode step, moving these bolts. So I'm going to pick these bolts and move them out. And maybe at the same time I'll move these two. They could be in the same step. So with all those bolts selected, we can rough move those. And then maybe just one more thing I can do is take these nuts and move them also. Okay. Let's also move these guys, make a step out of these bolts that need to move out. Okay. So I think the real point there is I've just done a rough move of logical components that need to be exploded. At this point, what I want to do is pick a exploded view that makes sense to kind of space these out and show them correctly. So I'm just going to center my view at a slight 3/4 and then make a new view called exploded view. And with that, now I can just start adjusting things by just selecting these steps. And you notice how everything's kind of moving logically. And this one needs to move out a bit more. My goal here is to show everything exploded so it's not overlapping other parts of the model. So right here, I want that bearing and bushing to show apart from this casing. And then as I start doing that, I can just kind of optimize the view for my drawing. Here, these could move a little closer. And I know that my Explode 2 now can move a little closer to show those. And then the bolts maybe are too far out, so I'll just move those this way. And these ones can move in a little bit more. And separate these. So actually, these ones probably want to move here, and then the nuts want to move out, right? So that's my methodology, in that it's very cool because exploded views are parametric, and you can treat them that way by the way that you select and group components for your explode steps. And then once everything is kind of logically exploded, you can start to move things so that they're out of the way of other parts. And that's what I've done with these, this last part of this video, is to show you how you can do that. And it's a very good methodology. It's worked for me. I hope it works for you. Also, a lot of times I'll start to put in explode lines, which I think are kind of cool. And you can do that also, like for all the bolts. I'll show one really quickly here. So if we want to put in some exploded lines, then we can do that. The way those work is I just grab any cylinder, make sure the arrow is going in the right direction. Okay. And then I want it to connect with this casing right here. So for these bolts, and you just keep repeating that. For these nuts, I want to try to grab the center, make sure the arrow is going in the right direction, and connect that all the way through to the adjacent bolt. That can be a little hard to do, but with a good guess, it's probably this one. And there's my exploded line sketch. And then you just repeat doing that. And of course, it's all parametric, because when you collapse it, they go away. And then when you move components, the exploded lines should go with them. Okay, not to belabor exploded views too much, but that's my methodology. And you can always go back to the correct exploded view.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project, or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.